Here's an example of writing the equation of a quadratic from a table. Here's our table, and we don't even know if this is quadratic yet. So first we're going to find out if it's quadratic, and if it is, we're going to write the equation. So to find out if it's quadratic, I do my first level of differences. So I'm subtracting 0 minus 2, that's going to give me a negative number, 4 minus 0, and I go across and I do all my subtractions. If those numbers were constant, then it would be a linear equation, and they're not, so we know it's not linear. Now we're going to do our second level of differences. So our D2s, 4 minus negative 2, and we got 6. So all of our D2s are 6s, our second level of subtractions. So we know that we have a quadratic. Our second level of differences give us a constant. We find our differences for our x's, and we have a constant of 1. So we know we have a quadratic. So we want to find the equation of the quadratic in standard form, which is y equals ax squared plus bx plus c. We know that if our differences for our x values are constant and 1, then there's a little trick. To find the a in the y equals ax squared plus bx plus c, all we need to do is take the 6 and divide it by 2. We know that 2a equals 6, so a equals 3. So we found our first coefficient for our quadratic in standard form. So now the next one we're going to find is c. We notice that we have our 0 term. So 0, 2 is part of our table. If we have our 0, we can plug x equals 0 in to our general quadratic. So x equals 0, y equals 2. We're going to solve that, and we're going to have c equals 2. So a equals 3, c equals 2. The only one we need now is b. So to find b, we're going to plug in any number. And I picked 2, 4 to plug in. I'm going to plug in x equals 2, y equals 4. We already know that a equals 3 and c equals 2. So when I plug all those numbers in, I get b equals negative 5. So we have a equals 3, b equals negative 5, c equals 2. Therefore, the equation of our quadratic is y equals 3x squared minus 5x plus 2.